Hello everyone. Today in this video we'll be covering the topic of metallic bonding and its properties. Now we have already studied metallic bonding in quite a lot of detail in O levels. This is just as it was then, and now if we look at the structure that I've drawn, that is the structure of a basic metal. Now, inside a metal, we know that there are positively charged ions, which is denoted by this plus in a circle, and that is surrounded by by electrons. Now, these electrons, the yellow electrons, they are basically a sea of delocalized electrons, meaning that as we discuss this entire structural theory, we call this the electron sea model of metallic bonding. And this basically tells us that the metal atoms in a sample basically contribute to their valence electrons to form an electron sea that is delocalized throughout the metal. So basically what occurs is that the electrons are submerged within the sea of electrons, and they are in an orderly manner. We can see that they are quite structured around the entire cation uh, layer, right? Now, this we already know, and this is what exactly leads us to the properties of metallic substances or metals. Now, the first property that we'll be discussing is high tensile strength. Now, what exactly this means, this very basic property, it means that the electrons, the delocalized electrons and the cations have a very strong force of attraction between them. This force of attraction is responsible for the strength of metals. This is exactly why a lot of energy has to be put into breaking a metal. That is why when we hit a hammer, a very large sledgehammer, that maybe bends a metal, but it doesn't break it. Breaking a metal requires a lot of energy because we are breaking the strong metallic bonds in the metal. And this is exactly why it has a higher tensile strength. Now, electrical conductivity. Quite simply enough, we have mobile delocalized electrons which are moving around. This movement of electrons will conduct electricity, which basically conducts electric currents. Now, the next properties that we'll be studying are heat conductivity. Now, suppose you touch a metal that is just sitting in your room somewhere, your sharpener or whatever, a metallic substance. Now, if you touch it, the metal will feel cold. Why does it feel cold? It feels cold due to a single reason, because of heat conductivity. Metals are very good conductors of heat, and this happens because the delocalized electrons in the metal conduct heat away from your hand much faster than the localized electrons in covalent bonds in wood can absorb the heat. So suppose if you touch a piece of wood that is sitting in your room, it may feel normal, right? It may not feel warm or cold. It may just feel at room temperature. That is because it is an insulator of heat. It will not take away heat from your hand, and neither it will do anything. It will just feel normal. But if you touch a metal, it will feel quite cold, and it feels cold because the metal is a conductor of heat. It is a very good conductor of heat, and it will try to conduct heat away from your hand much faster than any other substance. So that is why this heat energy leads to kinetic energy in the movement of electrons. So you don't need to know this much detail in it, you just need to know that they are good conductors of heat. Now moving on to the boiling and melting points. Now melting points in metals are basically moderately high because the forces of attraction in between the delocalized electrons and the cations have to be broken. So a lot of energy have to be put in them, and so the melting point is obviously quite high. Now the boiling point is even more high than that, because The delocalization remains in force until the metal boils. So, boiling a metal would require a lot of energy, a greater amount of energy, because all the forces of attraction have to be broken for boiling a metal. So, this you have to keep in mind, that the boiling point and melting point are always quite high in a metal. Then the last property that we come to, malleable and ductile. Metals are malleable and ductile. What that means is that due to the cations spread across the metal in a regular manner, they are surrounded by the sea of electrons, etc. Now, in regular layers, they can slide over each other if you hit them. Meaning, if I just draw the structure of metals that we do, and suppose all these white ones are positive ions, if I push this, it'll just slide over and it'll be the same thing, so it doesn't really matter, right? It'll still remain the same. So that is why they are malleable and ductile. They can be bent into shapes or turned into wires, and that gives them this property of malleability and ductility. And with that, we end the chapter of metallic bonding and its properties. All of these are quite basic, and these are only some of the properties. Ahead of this, there are other properties of metals also that you may look up, and that is it for our syllabus. Thank you.